Thank you. So now we go over to the next compound interest. So the difference between compound interest and simple interest is the accumulation. So why simple interest is accumulating only based on the principal. For compound interest, it's accumulating based on the principal and also the interest rate, interest earned in the previous year. In the sense that if I should deposit $1,000, if I should deposit $1,000 and I'm earning and I think the typical example of this is what do you call it? Let me remember. What do you call this market that stock market that yes, maybe stock market or something 500 SME 500. Let's assume you deposit and or maybe you deposit anywhere and you are earning at a constant rate of 3%. It means that after that 1 year, they will add up the 3%, whatever you earn, to your principal. And the percentage that you'll be earning, your earning for the next year, after that first year, will be the percentage of that principal plus your interest. Hope it's clear. This is why you say that something is compounded. Is the principal plus the interest. So we are getting the percentage interest of the principal and interest of the interest that you have earned previously. Right? Good. So the textbook definition that I have here is compound interest is a fundamental concept in finance that allows an initial sum of money, which is the principal, to grow at an accelerating rate over time. This happens because interest earned each period is added back to the principal. So unlike the simple interest where everything is constant. So here, the interest rate is added back to the principal. And then the next period's interest is calculated based on this new interest and the principal added together. Right? So some of the key components here is, one, we have our principal, which is the initial deposit. Right? So we still have our, for compound, okay. We have our principal. Which is the initial amount, is initial money deposited or the initial money. We also have our rate, which is still the same thing. Some of these components, our rate, the same thing. Then our N. So now this is the number of times the rate is happening. This is the number of times. So something, the money can be accumulated annually. Annually means it's accumulating once in a year, or semi-annually, maybe twice in a year. So this is the number of periods this is happening, or maybe quarterly. That means after, in a year, that means 4 times in a year. After like 4 months, it accumulates. After 4 months again, it accumulates. So you can have quarterly, annually, or even monthly, our N. So our N here means how often the interest is calculated and added back to the principal. So most times, or sometimes, it doesn't necessarily mean that it could be accumulated only annually in a year. Then our time, T, which is still the number of years money is invested or borrowed. Oh, we have our N. We have our T. Then final amount. So this final amount is how much we are getting in total. Final. This is how much you are getting in total after everything, after accumulating the compound interest. So the formula for finding compound interest is A. So this compound interest is represented as A. So we have A equals B into 1 plus R over N power N T. So this is the formula for finding compound interest. Let's solve some problems. So, if you deposit $5,000 into an account, into a savings account at an annual interest rate of 5%, that means if you are depositing P, it will be what? $5,000. Right? Then our R is 5%, which is 0.05. Compounded monthly, that means this will be compounded monthly. That means 12 times in a year, right? That means our N is 12. For 10 years, okay, 12 times for 10 years. Hence, here is how the compound interest will be calculated. How will it be calculated? So we now have everything, right? Do we have the T? The T here is 10 years. T is 10 years. So we have everything now. All we need to do is to plug in everything in our formula. So the final amount, which is our A, is equals P, $5,000 into 1 plus our R is what? 0.05 over N is 12. Power N is 12 times T times 10. This will give you 120. Hence, you have our A is equals 5,000. Can you do this operation? 0.05 divided by 12 plus 1. Do this and let me know what you have. First of all, this will be 120, right? So this will be 120. Okay. What did you get?
I got 8,235.0.
In total? You mean
Oh,
you solved everything? No, I want what we have inside here. 0.05 over 12. Whatever you have, add it by 1.
1.00417.
1.00417. Good. Now, everything here, raise to power 120. Now, when we get to the indices as a topic, understand the power of how this thing accumulates. This means this number coming this number of times, coming 120 times. So, this is so powerful. Power of exponents. Because indices is the plural of the word index. And index means power or degree or exponents. So this is more like an exponential function. So this raised to power 120. Let's do all the whole calculation together. What do you get as the final amount? What's our final amount? What's our final amount?
$8,235.
And 5 cents.
That's all?
And 5 cents.
Okay.
Very important.
Okay. So now this is the final amount. So this is money that you'll be going home with after the accumulation, after 10 years. So if you want to know how much that you earn, you have to subtract this final amount from the principal. To find the compound interest, the interest compounded, which is compound interest. CI, compound interest, is A minus B, the final amount minus principal, which will give you, this should be dollars, sorry, right? We have 8,235.05 minus 5,000. Hence, you have our compound interest as 3,235.05 dollars. Is that correct? Good. Okay. Let's solve another problem. So, Emmanuel puts $20,000. So, so you know, $20,000. I'm like, imagine if my father should see this. I say, oh, Emmanuel, so you have $20,000 somewhere. I'm like, they might be watching my family. Imagine saying that I invested $20,000. Honestly, after this 40 hours, you have to call me an emergency meeting. You have to provide that $20,000. Honestly. So it's a very big money. You want to convert it to our currency, Nigerian currency. It's a big money. So it's not me. I didn't put it in $20,000. It's not me. It's Luke. It's Luke. So Luke puts $20,000. Yeah. Ooh. Anyway, it sounded $20,000 in a savings account. In a savings, so pay $20,000, paying 8% annual interest. Interest of 8%. So this is 0.08. Is that correct? So the next point, compounded monthly. That means our N will be 12. Our N will be 12. It means that if it's compounded monthly and we have 12 months in a year, it means that it will be compounded 12 times. And how much money will be in the account of Luke after 40 years? So our time is 40 years. Have we gotten all our variables? I've gotten everything, right? So what are we doing basically? From this formula for simple interest, which is A, final amount equals P into 1 plus R over N power NT. We are plugging in all the values of all the variables here. So simply everything you have here equals the principal, which is principal is 20 into 1 plus R. The rate is what? 0.08 over N. Our N is 12. And Our N is what? 12 times our T. Our T is 40. Is that clear? Okay. Now do this basic simple operation. Simplify this and let me know what the final amount is. So whatever we get as the final amount, to get our compound interest, you have to subtract our final amount from the principal. First of all, let me know what the final amount is.
485,467.
485,000.
500 or 467. 467.
Okay. 467.
71 cents.
71 cents. So this is what we will be having after 20 years. After 40 years. You could notice the difference between the simple interest and compound interest, how this accumulates. Right? Because of this power of exponential function, the power of exponent here, it goes so high. So now to get the simple interest, the compound interest, you now subtract this final amount from $20,000. So you just have to take away $20,000 from here. What do we have? We have 465,467.21 cents. So this is our compound interest. This is our final amount. So sometimes these are not always linear. Sometimes you could be given all the information. You could be given the compound interest or the final amount, and you'll be asked to find either the rate, the R, just like we did in simple interest. So what you have to do basically is, from the formula, make that particular variable the subject. And by now we are all familiar with what change of subject is. Once we make it the subject, we now substitute the value of everything to get that variable, what it is. As simple as that. Okay, so now, somebody invests $50,000. So who is investing? Okay, so we have to go on a 10 minutes break. When we come back, we'll continue. Not 10 minutes, let's go 8 minutes break. Oh, come back. 8 minutes break. Let's come back by 2:24. Right? Let's come back by 2:24.
I gotta remind you of that.
Say the thing. I'm waiting.
I think this is way better. This is really
Right now our compound is supposed to be 4 hours and 46. So
But like, doesn't matter if we have extra guys all day.
yeah, but I mean that's great.
More time.
You don't need to get the rest of the still 40 hours. If we're way behind, that's better. But if you're ahead, that'd be a problem.
40 hours. How y'all feeling? Feeling good?
back to Arkansas and back. It's still
Here's where we're at. We got a little progress bar. Very underwhelming.
I'm sure everything will be fine.
Yeah, we're at 6
I
hours.
just wasn't filming that whole time.
Oh, that's
They're going insane. You made a program for us.
Oh, yeah.
Show it off.
Progress bar.
Yeah. He's stealing more of their pizza. But I mean, it's free. It's
Recording?
recording this time. I can do that. We had to press the red button. We'll go to make it work.
Yeah, I think we're all going a little bit crazy. I
I was deciding on zoning out.
that's good.
Yeah. The only one I wanted was Dawn. Taking that break.
I gotta stretch my legs the whole way down. See that? Yeah, I started to run. I'm really gonna look back and see the light in our eyes die.
That's a percentage bar.
Yeah, percentage bar. We're almost at 20%.
What's I'm AJ.
I had so much time that I worked on.
I brought my switches.
Oh, that's awesome. What's your right here? That's fine.
It just invades my life.
Okay.
I have an ancestry in Denmark in general, so I'm not really sure what area this is specific from. We came way back before
Nice simple name. Yeah. Still unique.
Yeah. Somewhere down the line, I'm related to the Walmart. Just not close enough to have any kind of stake in that.
Hi, do you guys mind if I film you guys?
Like you have like one.
So, how do you guys feel? I don't know if you guys hear.
I'm feeling alright. I'm already lazy. I'm tired of sitting. Honestly. But other than that,
I'm getting worried for when 24 hours. I'm already getting a little sleepy. It's not good sleep. But I have trust. I trust the
I think it's the pizza. I think the pizza's got us a bit sleepy. We'll see.
What are your two majors?
I'm a physics.
Hey, you could. Oh, interesting. Okay. You're science. Okay. Not engineer.
No.
That's very interesting. That's very abnormal. Yeah. Majority here at engineers. It's like 30 people. 5 that's engineers. Are you an engineer? No, I'm not. I do data analytics. I love numbers. I'm the guy. What year are you two?
I'm a senior.
Senior. Right. So that's like a 50-50 split. Freshmen and seniors. They're freshmen. There's majority. That is really interesting, right? There's like no juniors.
Yeah, they do.
But you guys still have 40 hours? So everyone's still feeling optimistic. This is great. I'll check it in a few hours.
Thank you. Like the audio. My dad used to work out when I was really young. Whenever he moved back during the summer, growing up, I just went on TikTok with my dad to be like, and I just love the geography, so I was like, I want to come here after I was itching to get out of my home state by the end. I just, like, anywhere but here, but preferably Utah.
There you go.
Now I'm not so much of a fan of, but it's nice. I don't know. Utah, yeah, is a really bad trip. Yeah, I just like it. Yeah, it's definitely a thing. Because I always like it's yes, it's a nice bar scene, but I want more like not bar scene, more like where you just sit there having mimosas, have wine,
I'm sorry.
it's okay. I just assumed. Yeah, but how much do I have? Well, you're not going to learn much. Just say that.
Hello, welcome back. Let's continue solving problems involving compound interest. So, okay. So, who is investing this time? Who wants to invest?
I want to invest.
Oh, okay. Hunter. So, Hunter invests $50,000. Oh, this is huge.
Money back.
This, I'll come and meet you after this class. Hunter invests $50,000 into an indexed annuity that's averaging 8.4% per year, compounded semi-annually. That means semi-annually means it's compounding twice per year. So our N will be 2, right? So at this rate, how many years will it take for her, for his account, or for Hunter's account to reach $1 million? This figure is huge. I want to. Okay, so from this information now, Hunter invests $50,000, which is the principal.
Yeah.
$50,000, right? So into an index annuity that's averaging 8.4% per year. So the rate will be what? 8.4%, which is 8.484 over 100, which is 0.084. Is that correct? So, per year, compounded semi-annually, that means our N is 2 times per year. At this rate, how many years will it take? That means our years is not known. We want to find how many years it will take Hunter to make $1,000. That means this will be final amount. So how many will it take Hunter to get to 1 million dollars? So this is the information that we have. So basically, we are plugging in everything that we have here inside our formula. Right? So from here, our principal amount is what? $1 million. Equals, principal is what? $50,000. Into 1 plus, our rate is what? 0.084 over n. Our n is 2. Here we have 2, our n again, times our t. Our t is unknown, that means here we have 2t. Right? Good. So, from here now, what do we do? The end now is to make t the subject. That's the end, because we are looking for our t and not the final amount. So we want to make t the subject. So from this, you want to take out the whole of everything we have here. So we're dividing both sides with $50,000. Right? So if you divide this side with $50,000, and also here, $50,000. This will cancel this. Is that correct? $1 million divided by $50,000 will give you what? $20,000, right? So we have just 20, right? 20.
Yes.
0 cancel 0. 0 cancel 0. 0 cancel 0. 0 cancel 0. 100 over 5. 100 divided by 5 is 20. Just 20. So we have 20 equals. Let's do these operations inside here. 0.084 divided by 2. Whatever you get, add it by 1.
1.042.
1.042. Everything power 2t. So at this point, what do we do? Whenever you encounter such a problem where what you want to make the subject is in this form, you take square, no, you take log of both sides. Log to base e, you take log of both sides. So taking log of both sides, log 20 is equals log 1.042 all power 2t. And from this can come down because there is this basic law of logarithm that says, one of the rules that say, if you have log n power k, this is equal to k coming down, we have log k log n. Now when we get to indices logarithm, you get to understand this law better. Not some of the basic law of logarithm. So whenever you have this is equal to this. And now from here, you can see that the value of our k here means everything in the power. That means everything can come down. Is that clear? Now we have log 20 equals 2t equal 2t log 1.042. Applying this basic law of log grading. But remember, we want to make t the subject. We want to make t the subject. And it means from here, we now divide both sides with the coefficient of t. To eliminate everything here that's close to c, you have to divide here by 2 log 1.042. If you do this, if you do it here, you have to do it in the other side of the equation, right? So by fair, it's fair you do it here to have 2 log 1.042. So 2 we cancel 2. Log 1.042 will cancel log 1.042. Hence you have that our t is equal to everything that we have here. Using your calculator, log 20 over 2 log 1.042 will give you what? Then that's the value of our t. What?
I got 36.4073.
36.4073. So approximately 36 years. That means because t means time. It will take 36 years for Hunter. You should have a very long way to go to make this money. 36 years. So it will take you 36 years to move from your initial principal amount, initial deposit, to $1 million at this rate, and having your end semi-annually. That means when it's accumulating twice a year. You take it at 6 years. Good. So we have another example, which is somebody puts $20,000. Who is investing this time? Who have not invested before? Carol invests $20,000 in a savings account, paying 8% annual interest, compounded monthly. That means yours is compounding very fast. That means monthly means 12 times in a year. So our N is 12. So at this rate, how much money will be in the account after 40 years? That means how much will be the final amount? How much is our A? So this is pretty straightforward. Because here we have that our P. Colonel invests $20,000. $20,000. Right? Paying 8% annual interest. So the interest is 8%, which is 0.08. Is that correct? And it's compounded monthly. That means our N is 12. Another information is at this rate of 8%, how much will be in the account after 40 years? That means our T is 40 years. So we are looking for our A, final amount. Is that clear? Then from our formula, I have to plug in everything. We plug in everything. Now, I want us to do the plugging in. Right? I want us to do the plugging in. Oh no, wait. Let me do the plugging in. Then the next question, you attempt the next question because the next question is kind of technical. You're not looking for the final amount. It has to look for one of the variables. So let me plug everything in. So from here, we have the principal, which is $20,000. We have 1 plus R. What's our R? Our R is 0.08 over N is 12. We have 12 as N times T. What's our T? 40. So our A is equal to, please do this basic operation. Do this and let me know what our A will be. 12 times 40. You do this, after this you raise it to power to whatever you get from here and multiply. At the end of the day, what's our A? You can use your calculator. Use your calculator.
4, 8, 5, 4, 6.
4, 8,
4, 6, 7.71.
4, 8.
5,
Uh-huh.
4, 6, 7, 7.
Point what?
7, 1.
0.71. Did you solve something like this before?
Yeah.
We have solved similar problem like this. Oh, we have solved something similar. Oh, good. I know that we have seen something like this. Okay. Someone wants to have $2 million for retirement after 45 years. Oh, you. What have $2 million? Yeah. Okay. When you rush and raise up your hand, I shall not use my name. I shall not use my name. This is kind of my own. I have billion. Okay. So Andrew, right?
Connor.
Huh?
I'll take
Connor.
it.
Sorry.
No, I'll take it.
I mean your name.
It's Connor.
Connor.
Yeah.
Connor. Who is Connor?
My middle name's Andrew though.
Andrew.
So you can call me Andrew.
Connor. And Connor wants to have $2 million for retirement in 45 years. He invests in a mutual fund, paying an average of 9.5% each year, compounded quarterly. So quarterly means it's compounding out of 12 after four months, like 4 times in a year, right? So now, how much should he deposit into his mutual funds? So he's contemplating, Andrew is contemplating how much to be deposited inside this mutual fund to earn this $2 million after retirement. Okay. So let me write out the variables. So Canon wants to invest $2 million, that is the P is $2 million. For retirement in 45 years, that means our T is 45 years. Then he invests in a mutual fund, paying an average of 9.5% each year. So our R is 9.5%. Compounded quarterly, that means our N is 4. So 9.5% is 0.95, right? 0.95. 0.95.
Isn't it 0.95? That would be
0.095. Thank you. 0.095. Okay, so how much? You have a question?
2 million the A, because that's the amount he wants to have, and then
No, this is the amount that Canon Andrew wants to have after 45 years. So he's now thinking of. Thank you. Thank you. So this is the final amount that, and you represent final amount with A and not P. P is represented by the initial amount. So how much should he deposit into his mutual fund? That means he's looking for P. P is the unknown from here. So from this, having all this information now, I now want you to solve this. Look at our formula here. I want us to just take 3 minutes to solve this. So you can solve this in pairs, in groups, interact, share ideas, and tell me what our P will be. It's okay if you don't get it after 3 minutes.
What are you doing?
but no, I'm saying it is. I'm trying to figure it out. Realistically. Realistically, I'll retire in 43. Yeah.
A minute more. 1 more minute. One more minute. It's okay if you are not able to solve it.
You didn't stop me. That's why I was wrong.
1 more minute.
What you want?